Okay, folks, this quick transition piece, half transition. The only difference for this one will be that the base has two levels. So what you need to do with this one, they've already started the process for you in this top view here with a bit of the labeling to show you where your halfway point needs to be, where your half transition needs to start from. 1A, so we just create a line here. We're going to use the same naming convention that we always do. We'll go anti-clockwise. So on the top plane, we're going to go use letters A, B, C, and D. And then anti-clockwise, going from where we started with the 1, each corner, 2, 3, and 4. So the only difference with this one, of course, is that because you have a bottom that is not, as you can see, horizontal, can you see that if the rule is horizontal, it's actually not a level. So when you draw the two lines that you're going to create your true length from for the inclined planes, what you need to do is you need to create one line that's coming from this corner here and another line parallel to it coming from this bottom. So that's the main difference with this type of work. All the rest of it's going to be the same as our previous 10 videos that I did. So that's the lines that we're going to use to create our real distances from the inclined planes, and then we just do our vertical using our set square. So that's going to be used for that. We need to triangulate each of these inclined planes. This plane at the top view is leaning down. See the way my hand is going? So that's going to be a triangulation 1B. We're going to have a 2C. People have asked me, well, how do you know you're triangulating in that direction? I'm pretty sure it doesn't matter, but if you ever find that you're trying to swing your arcs and you haven't got the line you need, you can always do another triangulation and create a true distance for it. So there are our triangulations of our planes that are inclined. Remembering, of course, that anything that is perpendicular to the viewer, so the pencil is the viewer, perpendicular to the viewer in the top view is this way. These lines in the top view are going to be true lengths in this front view. Okay, so 1A and D4 a true length in this view. So in this view here, down the bottom, you've got 1A, which is a true distance here, and you've got 2B, which is not a true distance because it's inclined plane. On this end here, you've got 3C, and you've also got 4D, which is a true distance. This is a true distance here. So that's what you need to do for that. And then what you need to do is we need to work out our lengths that are triangulated. So 1B is the first one. So we grab our trusty compass, which is a complete piece of rubbish, and we go like that, and we go, because it keeps slipping on me, and go like this, 1B, and then we create our hypotenuse. And then we go 2B, which I have a sneaking suspicion is going to be the same distance. And it is. So 1B and 2B are the same. This length here. Then we go 2C. And 2C is an inclined plane, so it's going to need to be worked out the hypotenuse. 2C, and it's still going to this side here, so it's still going to be on this top line. So you go like that, 2C, so that's our 2C, and then we need to work out our 3C, which is also an inclined plane, but this time 3C is going to this bottom line, okay, so we need to swing the arc here, and say 3C, and then we have 3D, which is also going to the bottom line. And that's all the lines I think we're going to need. So now what we need to do is we start with our 1A, which we said, because it's perpendicular to the viewer, is a real length here. So we can grab a ruler if we like and measure it. It's about 3.8. So let's just go like that. Now if you want to be really super accurate about it, you could use your set square and make sure it's 90 degrees. It's not really, so yep, it's always good to try and get these as accurate as possible. I'm in a hurry. Okay, this is 1A. I want to go to bed. So that's our first line, 1A, which is this line here, 1A. Okay, so we draw it as a vertical. Now we're going to go from A to B, and A to B, because it's horizontal, it's a true distance. So I'm going to work it out with my compass, A to B, and I'm going to swing from A, create an arc, and then I've got to find another line that runs to B. Okay, and the other line that runs to B is 2B. We can take 2B off here, and A to B. Oh, so we want to take 1B, which is the same. 2B, 1B, the same distance. So we swing from 1, and that's our first point. Okay, B, and we can join that up. And then we want to go from 1 to 2, which is a true distance. Swing an arc. Okay, we're swinging from 1 to 2 because 1, 2 was a true distance. So we've swung our first arc 1 to 2. We need to find another line that's running to that 2 point. Okay, and there's one running from B, B2. Okay, which is this line here, 1B, 2B. Okay, so we'll take that distance. Okay. And we'll swing it here. That gives us our second point. 1, 2. So now we can join those lines up. Okay, now the next thing, we go from B to C. True distance, because it's horizontal. So we're going to swing our BC arc, and we need another line that's running to BC from 2. We're going to swing this arc this way, and from 2 we got 2C. 2C is this line here because it's not a real length because it's an inclined plane. So we're going to swing our 2C line, and that takes us from B to C. And we also need to go from 2 to 3, which is a real distance, because it's horizontal. So we just grab it like this, 2 to 3, and swing our arc, 2, 3. So 2, 3, we need another line that's running from C, C3, which is this distance here. We go like that, and that gives us our 2 points. That was B to C. Sorry, B to C. And that was 2 to 3. And now we have our second panel complete. I've got one more panel to do. This is going to be a weird one, I can tell. We need to go from C to D, which is a true distance. There's a very short distance at that. I'll just show what I'm doing, just so you know. C to D, true distance. Okay? Because vertical. So I'm going to take that distance, and I'm going to put my compass down on C and swing that arc. And I think it's got to go quite high. I'm just getting that feeling. Now, I would suggest you invest in a really nice compass that's nice and tight and not the cheapest one you can buy. So that's our first point, C to D. I need to find a point from 3D. If you look over here, I've done C to D, 3 to D, and I've already plotted point 3, so I can go 3 to D. So 3 to D is on here as a real length, as a hypotenuse. I grab it, and I need to swing that arc. That'll give me my final bit of arc here. And there we go there. So that's got us our point C to D. I just probably should label it there so that we're not. Don't be afraid to rub out and correct. Make sure that people can see exactly what you're doing. So that's C to D. God, I wish I brought my glasses. And then we go 3 to 4, which is a real distance because it's vertical. So we'll grab our distance 3 to 4 off the top view, which is a real view, and we'll swing 3 to 4 as an arc. Now what else runs to 4? We've got D4, and D4, is it a real distance? Of course it is, because it's perpendicular to the viewer on the top view. But note, if I take it from here, am I doing the right thing? No, because if it's perpendicular to the viewer, you have to take it from the front view, which is D4 on the front view here. Okay, they've given it to you. Okay, so that's something to really look out for, because that'll be your last point, and you'll get it wrong if you don't do it the right way. So that's D4, crosses over there. Beautiful. So now we go here, 3 to 4. We've got all the points we need. We join that 3 to that 4. But this last line, as you well remember, needs to be a dotted line. Okay? So we go and we go cross, 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 cross. Show it's the seam. And so that is, in a nutshell, our way of doing a half transition for a front view that is not level. Hope that's helpful. Make sure, like I said, that last view, D4, okay, the tendency is to go put it up here because you think it's a true view, because you're getting all the other true views from this top view, but these views here that are perpendicular to the viewer are only true lengths when they're taken off this front view here. And that is a trick for new players like me. I did this twice before I worked that out. So now I'm saving you that hassle, okay? So take these true lengths, these horizontal ones that are perpendicular to the viewer on the top view, from this front view. And also remember that even though this is a true length here, if it's perpendicular to the viewer, this distance here, 2b, okay, is not a true length because it's inclined. So you have to put your compass here, swing your arc, and work out the true distance over here. So lots of stuff to think about. Hopefully that helps. It's an example. You can have a look at it over and over again. Do a few. And like I said, in your exam, if you get these naming convention right, get all your letters and numbers down, that's marks for you. If you label this bit, marks for you. If you get your true distances off your triangulations, marks for you. And if you get it to this point, happy days. Bye.